We will encounter related rates problems as worded problems, and here is a simple example where the area of a square is decreasing with respect to its length at a rate of 0.2 meters squared per second. So that gives us a clue that we should use the area, which is related to the length x, so that's equal to x squared. And the problem is basically giving us a rate of change in meters squared per second, meaning that we need to differentiate the area with respect to time. So we're assuming that x is a function of time, and using the chain rule, which is the basis of related rates problems, we differentiate with respect to x first and multiply by dx dt. And you can see that we're told to determine the rate at which the length is decreasing when the length is 2 centimeters. So because the area is decreasing, we need to put a negative sign behind this derivative. So it's decreasing at this rate at a specific length of 2 centimeters or 0.02 meters. So effectively this is the instantaneous rate of change of the area, because we're looking at a specific length of the square. And observing our units, when we divide through by 2x, we're going to cancel out one of those meters. And we obtain the following result of -5 meters per second. And that matches the units of the derivative on the left. The volume of a cylinder is increasing with respect to its height at a rate of 0.1 meters cubed per second. So the volume of a cylinder is pi by the radius squared multiplied by the height. And we're asked to determine the rate at which the height is increasing. So therefore the rate of change of volume with respect to time is equal to pi by the radius squared, which is constant, multiplied by the rate of change of the height of the cylinder with respect to time. And now we can substitute our values, so 0.1 meters cubed per second is equal to pi by the radius squared, so that will be 0.03 meters squared multiplied by the change in height with respect to time. And then solving for the rate of change of height with respect to time, we get 35.4 meters per second. And check your units.